Now we are looking at different techniques of finding the LCM. The basic definition of LCM is the least common multiple. So if you listed all the multiples of the numbers that you're trying to find the LCM for, and if you can locate the least of all the common multiples, then that would be the least common multiple. That's basically the definition of least common multiple. But as you saw in the previous problem, it took us a while before we actually found the least common multiple. And if the numbers are larger, the list of multiples that we have to make could be very long, and this is not a practical method for finding LCMs. So we're going to learn this other method. This is our second method, prime factorization method. And what is the prime factorization method? As the name suggests, prime factoring. So if we have a number 16, we are going to break it down and find the prime factorization for it. It's 4 times 4. 4 is 2 times 2. We have another 4, which is 2 times 2. And finally, we're going to write it in the exponential form. So what we've done here is factored 16 into its prime factors to get 2 to the 4th power. So we write it in the exponential form. So we're listing the 2's. So that's 2 to the 4th power. Now let's say we have a 24. 6 times 4 is 24. 6 is 3 times 2. And 4 is 2 times 2. So we have 3 to the 1 times 2 cubed. And we're going to write it in increasing order of primes. Remember, we have to break it down to the prime factors. Break it down until you can break down no further. So that would be 2 cubed times 3 to the 1. So here you've listed all the 2's. Here you've listed all the 3's, both in the exponential form. And why is the exponential form important? Because now we're going to look at all the 2's. So these are the 2's, and pick the larger of the 2. And the larger of the 2 is 2 to the 4th power. We look at all the 3's. There is no 3 in the first number. And in the second number, we have 3 to the 1. So that's what we pick, 3 to the 1, the larger of the prime numbers. So we have the LCM. So we pick the larger of the 2, which is 2 to the 4th. Pick the larger of the 3, which is 3 to the 1. Because there was nothing in the other number, this would be the largest. So your LCM is 2 to the 4th times 3. You have to multiply the 2. 2 to the 4th is 16. 16 times 3 is 48. So 48 is the LCM, or the least common multiple, of 16 and 24. So let's write that down. The least common multiple, LCM, of 16 and 24 is 48. Now if we had to find the prime, if we had to find the LCM using the prime factorization method, we're first going to factor 36. We can write it as 6 times 6, which is basically 2 times 3 times 2 times 3. 2 times 3 is 6. So this is 2 squared times 3 squared. So I write down the number 36. First I list the 2's. 2 squared times 3 squared is 36. 36 equals 2 squared times 3 squared. Now 42 is 2 2's are 4, 2 1's are 2. 21 times 2 is 42. We can break down 21 further. 7 times 3 is 21. So it is 2 times 3 times 7. So I'm listing all the 2s, the 3s, and then the 7s. Now let's look at 30. So we have 6 times 5 is 30. So we're using the prime factorization method, which means we find the prime factors. So it's 2 times 3 times 5. So it's 2 to the 1 times 3 to the 1 times, and then since there's no 7, I'm going to list the 5s in a different spot. Now what do? I pick the largest of each. So the largest 2 is a 2 squared. The largest 3 is a 3 squared. The largest 7 and the largest 5. So now once we've picked the largest, what do we do with it? The LCM is 2 squared times 3 squared. So I'm picking 2 squared times 3 squared times 7 times 5. So this is equal to 4 times 9 times 7 times 5. 9 times 4 is 36. 7 times 5 is 35. It's 1260 if I've done it right. Let's just try another way so that way I can double check. Okay, so that's the LCM of the 3 numbers. So LCM of 36, 42, and 30 is 1260. Now the other method is called the division by primes method. So what does the division of by primes method mean? So we have 20, 36, and 15. So I'm going to write it down. So I'm going to do division, and that's why I have this symbol, 36, 15. So I'm going to divide by what? I'm going to divide by primes. The lowest prime is 2. If 2 goes into at least one of these numbers, then I divide by 2. So 20 divided by 2 is 10. 36 divided by 2. If you can do it in your head, that's good. If not, just divide. So that would be 18. And leave the 15 alone. 2 times 5 is 10, 2 times 9 is 18, 15. So now we've exhausted all the 2's. None of these are even numbers. So now we move on to the next prime number, which is a 3. 3 goes into 9 and 15, so I leave the 5 alone. 3 3s are 9, 3 5s are 15. We have another 3, leave the 5 alone, divide the 3 by 3 to get a 1, and then a 5. And finally, the next prime number is a 5. So we divide 5 by 5 to get a 1, 1, and 1. You stop when you get a 1, 1, 1. And what do you do at the end? Look at all these numbers, multiply them together. So it's 2 squared times 3 squared times 5. And that is the LCM of 20, 36, and 15 is 2 squared times 3 squared times 5. So that is equal to 4 times 9 times 5. 5 4s are 20. 20 times 9 is 180. You can do the math, but this is the LCM. Let's try this using, so this was the division by primes method. So we're dividing by primes. Now let's find the LCM using the prime factorization method. So 20 is 5 times 4, and that is 5 times 2 squared. 2 times 2 is 4, so 2 squared. 36 is 6 times 6, which is 2 times 3 times 2 times 3, and that's equal to 2 squared times 3 squared. Next we have 15, and 15 is 3 times 5. Now we pick the largest in each bucket. Like, look at the 2's. We have 2 squared and 2 squared. Any one of them will work. Look at all the 3's. 3 squared is the highest of the 3's, and then of course the 5. Any one would work. You pick the largest. So 2 squared times 3 squared times 5 is the LCM, and we've used the prime factorization method here, and notice that we get the same number, 180, using both methods. So what are the three methods? One that works through a definition, through the definition of least common multiple by listing all the multiples. That's not a very practical method because the list could be very, very long. The other one is the prime factorization method, which the name suggests break down into its prime factors, pick the largest in the list in each of the primes. And then we have the division by prime method, which is dividing by primes. So suppose we have 16 and 24. Let's see if we can divide by primes to figure out the LCM. So we divide by 2, 2 8s are 16, 2 12s are 24, 2 4s are 8, 2 6s are 12. So we keep dividing by 2's first until we can divide no more. 2's are 4, 2 3's are 6. We have another 2, 2 1's are 2 and 3. And then of course we have to divide by 3 because we ran out of all the 2's. And finally our LCM is 2 to the 4th times 3 when you multiply all the numbers. So this is the division by prime method. This is the prime factorization method.